Hello everyone, welcome back to your favorite class, I'm sure, INST377. Alright, so welcome back everyone. So this week we're starting off with something really exciting. So this week you'll see there's two lecture videos, what we're doing now, and there'll be one more. So first, what we're going to be covering, at least in this lecture, is Git. So some of you might have heard of this before, but it is one of the most, I would say, crucial thing in a software engineer's toolbox, I guess, right? So Git is basically a software which basically allows us to control code and basically create a system for us to be able to ship code continuously and save it somewhere, right? We can't use Google Drive usually for code, right? So Git allows us to do it in a really well managed and simple way. Now, it's very interesting because Git has started to become very commonplace, and this is a skill which I am really hoping that you all learn throughout this semester, because this is one of those things that as you go into the workplace is extremely crucial, right? It's one of those things that, when we go into the workplace and, we start, like, let's say, we're hiring new associates or something like that, this is one of those things that we're like, hey, we kind of expect you to know Git, right? It's not something that you're really usually trained on. It's like, hey, like at a basic level, you should know what Git is and be able to use it, right? Knowing how to clone a repo, push to a repo, all those things, right? And so anyone we hire, that's like, we just say, hey, go and do this thing. We don't like give a training on how to use Git. We just go say, hey, go clone the repo and do all these things, right? So Git is actually a very useful tool to know. So I'm hopeful that through this lecture and throughout the year as we're using it, you'll learn a lot about it. And so going forward for all assignments, we will be using Git. So week 2 onwards. So with that, let's go ahead and hop right in, get started. I'm really excited for this, and yeah, let's get started. All right, so let's dive right in. So we're going to start giving an intro to Git, and yeah, we'll go from there. All right, cool. So first of all, Git. Is that even a real word, right? It sounds made up, right? Some of you might have heard it said as JIT. Whoever said that is wrong. It is Git. At least I think it is. But is it a real word? Well, the answer is yes, it is a real word. Apparently it is, right? So Git stands for Global Information Tracker, right? So I kind of lied. Git is not a word. It's actually an acronym. But at the same time, we use it as a word throughout throughout normal lexicon, right? So Git just is the word that we use. So Git is a industry standard for software engineering, right? So now pretty much everywhere you go, you use Git or some form of Git, basically to commit code, to basically push code, to basically do everything to save and manage your code. And as we go through this lecture, you'll see why it's so great, right? So most workplaces use Git to maintain and version their code, which is really important, right? Before, I have seen that people, would go and upload their code to a Google Drive or et cetera, and it's very hard to manage that way. So Git really changed and revolutionized how code is actually shipped, right? Now, as I mentioned, Git is an amazing asset to learn, and effectively, it's now a baseline concept for most engineers. Like, if a engineer doesn't know Git, it's kind of shocking in general, right? We've had, like, that's just how we hire, basically. Now, what's interesting is Git actually had many competitors, right? Git actually is a underlying technology, which basically allows you to basically, version the code and everything, but it had many competitors. So Git had this competitor called SVN, Mercury, but Git effectively won the war of distributed version control. And I'll tell you, right, at one of my first internships, it was at a government contractor, we actually had SVN, and let me tell you, it was not fun to use. It was much more confusing than Git. But it's very clear why Git won. Git was very good in general, but yeah, Git had many competitors. Some of you might have heard like Tortoise SVN, those kind of things, and Mercurial and those kind of things. So there's a lot of options, right? So Git just tend to win, right? Now let's talk a little bit more about what is Git. So Git at its underlying like kind of core principle is a version control system. It allows us to version software, right? And effectively, it is used to maintain both large and small projects. And in both cases, it's very beneficial, right? So let's say you're building a solo project. Most people still use Git because Git is just the easiest way to maintain code, right? But in a large project, Git shines, right? Because what Git allows us to do is create like forks, it allows us to create branches and all these kind of things, these really very useful benefits, right? Which we'll talk a lot more about. And so it makes it very easy to maintain large projects, right? And one of its key features is that it allows us to cross collaborate across teams, which in a previous world was very difficult, right? Because if you think about it, right, if one team is working on one piece of the app and another team is working on another piece of the app, how do you maintain that and make sure that, everything is in sync? So Git basically allows us to manage project files and keep versions of them so that you can, one, view history, two, collaborate with the team, and also it introduces a concept of a feature branch and merging, which we'll talk about, right? Now, a lot of you might have heard of Git in different ways. So most of you have probably heard it in the context of GitHub, right? Now, it's pretty funny because GitHub itself is not Git. GitHub is actually just a tool on top of Git. It's kind of like a UI for Git. And there's a lot of different like kind of competitors in that space, right? So Git is the underlying software of the version control. So this was actually invented in Unix time, right? I don't remember. I believe Linus Torvald helped with the invention of Git. I don't remember how much his role was, but it was around that time. And Git actually was like Git is actually the underlying software, and all these other companies are built on top of it, right? So there are many implementations of Git, and some examples are GitHub, which most of you know, Bitbucket, which is by Atlassian, and GitLab. Okay, so GitHub, Bitbucket, Atlassian, GitLab. So I've used GitHub and I've used Bitbucket. I'll tell you, GitHub is great. I love GitHub, right? We have an enterprise GitHub at our company, and Bitbucket I've used in the enterprise setting as well. It also has some really nice integrations and has some really nice benefits which you don't get from other software. And GitLab is also very well reputed in the industry, right? So all of these are kind of just layers on top of Git, right? So at the end of the day, when you need to push code to Bitbucket or to GitLab, you still do git push, right? And we'll talk more about those commands in a bit. But it's pretty interesting. So now from there, let's start talking a little bit about how Git can be beneficial for history, right? And this is, in my belief, one of the best uses of Git. So let's say a dev checks in a file called main.py. Well, then a second developer makes some changes to the file and checks in a new version, v1.0.1, right? Now, the purpose of this, right? These changes could be months or years apart. And so what can happen is we can go back and see the changes. So let's say maybe a bug is introduced. We can go and see what line changed and see why it might have impacted. And we can also see who committed the code by this command called git blame. So I'll tell you a fun story, right? So at work, right, there was one time we were working on something. I mean, it happens all the time, but this is a specific instance I know about. We were working on something, and basically we broke this feature, like we broke the onboarding of our app, right? And so, all of us are looking into it. We're like, what happened? And, one of the devs goes and finds the issue, right? And basically what happened was they introduced a code change. And basically what happened was a code change was introduced, and basically they were running a asynchronous function, basically a function that runs like not necessarily at the same time, like it could run in the background, and they were not waiting for it to complete. So basically the page wasn't loading because it was like not waiting for anything, so it was just rendering it. And so this caused like onboarding issue, incident, all those kind of things, right? Now, what's interesting is, we were like, okay, great. Like, who did this? Like, what changed, etc. Right? So what happened was the dev went and did a git blame, and turns out that the dev who introduced or who found the change was the one who introduced the change, right? I cannot tell you about the number of countless times that, And this will happen to you probably at least once, right? You'll go in, you'll see, hey, you're debugging some code or you're looking at some code and you'll be like, oh, who wrote this terrible code? It's so bad. Like, and then you'll click get blame and you'll be like, oh, I did. And the amount of times that's happened is unbelievable, but it's a great way to see, okay, why did this change occur? It'll even tell you like what was the commit they put and what else changed during that time. So it's a really great way, right? So pretty interesting, right? So here's another example of different thing, right? So here, someone checks in a file called main.py, right? Dash checks in that, and that's v1.0.0, right? Now John on March 1st, 2022 has v1.0.1, right? And now Alice, right? Or sorry, I should say. So John introduces this new code, right? And there's a bug in this code, right? Hence the bug icon. But John introduces some bug. So now Alice goes and within the next 2 days is able to see, hey, what happened between these two, like what happened in the last few days, right? What changed, right? I can go back and see, hey, what is the changes between 2022 and 2020? And Alice is able to identify, oh, okay, here are the changes. Here's probably what broke it, and is able to put a new version of the code, right? And is able to even find out who or what the change was. So very common use case, and it's very useful in coding. Okay, so as we go throughout this lecture, you're going to hear me say some Git terms, and I want to make sure that you kind of understand them before we move forward. So first, you'll hear the term repository. So what's a repository? It's also abbreviated as repo, but effectively, this is the location of the code. Think of it as a folder, right? It's nothing more than a folder, right? Then there's branch. A branch is a specific copy of the code that branches off the main code. So for example, let's say I have a change, or let's say we're on the main branch, right? And you go and you want to make some small specific change. You'll create a branch called my specific change and make that change, right? This is basically a contained area of the repository. So it's an isolated thing, like it's kind of like living in its own separate little world. Then there's a term called merge. Merge basically means putting something that you branch that contained repository and pushing it back to the main code, right? Then there's pull request. Pull request is just a request to review a branch of code, right? At almost every major company, a pull request is required, right? So for example, at our company, to even get your code to deploy, one of the pipeline checks is you have to have 2 reviews for your code, otherwise it won't let you move forward, which is a good thing. Then there's commit. Commit basically means a commit is basically what records your changes to one or more files in a branch, right? And then cloning. Cloning basically means getting a repo from an online location and putting it or making a copy of it on your local file system, right? So this online location would be like GitHub, Bitbucket, GitLab, one of those, right? All right, so let's go on. All right, so now let's talk a little bit about git branching. So I briefly kind of went over that, but let's talk about it. Right, so first of all, what are branches? Well, branches is a version of the code that the developer is working on, right? It is basically a copy of code in a point in time, right? So let's say the code was updated yesterday and I make a branch off of it. It is a copy of that code from yesterday. And there could be other changes that happen to the main code, but that doesn't affect my copy, right? This copy is then worked on by an individual, right? So let's take an example, right? So first you have main. Main is a common term that we use in Git. It basically means the primary branch, right? So we have main. Now, someone says, okay, you know what? I see a bug in this code. I'm going to create a branch, right? So you see it kind of diverts. A branch off of main and work on this bug fix, right? So I'm going to work on this bug fix. Now what I'm going to do is then go and merge it back, right? So what I'm saying is main now has the branch that I worked on with my changes, and now that is the primary branch. So then someone else can now take this code and say, oh, okay, I'm going to introduce a feature. So they'll take that latest code, branch off of it, build that feature, and then merge it back, right? And you could also have a more complex scenario. So for example, let's say You have someone here, right? They take a bug and they also, someone different takes a feature, right? So this can happen, right? And so what'll happen then is both of you will try to merge and one of you will have a merge conflict, which will basically mean like, hey, you need to have my changes before I can move forward and push in my changes, right? So yeah, there's a lot of interesting things you can do. So this allows true isolation while working. All right, so let's take an example of, okay, what could be a feature branch? Well, let's take a look at a very basic website. So we have a header, we have a footer, we have a body, right? And imagine that this code is a repo, right? It's in a repo, right? So now day one comes and what we do, we assign 2 tasks. So I say, hey, Jim, go work on header and Alice, go work on footer, right? Now, both of these are just 2 tasks, right? But what we can do here is we can say, hey, Jim, you're working on the header. Alice, you're working on the footer. They, as you can see, are completely separate parts of the app, right? So Alice, you go and you work on the footer in your branch. Jim, you go work on your code in the or work on your code in another branch. And now, Alice can go and merge her changes without waiting for Jim, right? So Jim's working in isolation. Alice is working in isolation. So Alice might be able to say, hey, I'm pushing my code to production tomorrow, right? And Jim says, hey, no, there's a lot of changes. I need a week, right? And so Jim is able to work in isolation because his code is in a different branch. So these are features, right? So these are what we call feature branches, right? So Alice then goes and can independently push her code to production, right? Now, the next thing I want to cover is how Git repositories work, right? So how do Git repositories work? Well, let's take a look at this. So in the website like GitHub, Bitbucket, etc., you will have a remote repo, right? Now, let's say the left side is Jim, the right side is Alice, right? So what'll happen is Jim will say, hey, I'm going to clone the version of the repo and I'm going to work on it within myself, within my little bubble, right? And Alice will also clone a version of the repo and work on it in her bubble, right? And both of them will add and commit to their version of the repo. Now, what they can do is say, hey, you know what? We're ready to put these changes on the remote, right? So what they'll do is they'll run something called a push command. And that push command will push to the remote repo, right? Now, remember, they're still in different branches, so that doesn't necessarily mean they're overriding each other's changes. But their code is now on the remote, right? So instead of being on the local, it's now pushed up, right? And it's kind of hard to understand this, but think of it like this, right? Let's say I email you a PDF or I email you a Word doc, right? I email you a Word doc and then you say, okay, I'm going to download it and you make changes to it, right? So you make these changes. And then for me to get that file, right, you have to send that file back to me, right? So it's just like that. So for the repository, you clone it, you make your changes, and then for me to get it back, you have to push it, right? So, and we'll go through this exercise today so you'll get a better understanding of what happens, right? Now in Git, there are a lot of important files. So as we go through the lab today, right, first of all, you'll see there's a folder called .gitignore. Now, I want to really emphasize this. Please, I want to say that this file basically lists files or folders you do not want to be pushed. For example, right, passwords, right? You might have an environment file with passwords or local configuration, right? This is all very important, but should not be pushed because this could become public, right? For example, if you go and you push your password, right, that means it's leaked, right? Which is really bad, right? And then there's another thing called the .git, which is a folder. Now, this has a lot of git config stuff, etc. Do not touch this folder, please. It will break things. Do not touch it, right? It is not necessary for the level of Git we are using in this class, so don't touch that folder. Okay. Now, how do we install Git? It's a great question. So, in Mac OS, Git is mostly usually installed by default. If not, you can follow these instructions. And in Windows, there is a guide, which has this, right? So if we go here and open this up, right, there's a great guide, and it has both the Windows, Mac, Linux instructions. But yeah, so you can go ahead and install that. Now, one other thing that you will need to be able to do so you can clone these repos is set up SSH. Now, I could sit here and explain that, but I think there's a very short 1 to 2 minute video. Just go ahead, watch that, and it does a really good job of explaining how to set up SSH. It does a much better job than I probably could. So just go ahead, watch that, and you'll be able to do it. And also I linked to some docs that allow you to set that up. All right, so now we're going to take a quick detour and talk about Markdown. So what is Markdown, right? What are we marking down? Is it a sale? So unfortunately, no, that's not the case, right? Markdown is a standard language convention that allows us to create documents as code, right? And it's one of the preferred documentation styles for OSS projects. And companies have also been pushing for adoption. So I'll tell you, for example, right? In our company, we have actually been moving all our docs over to Markdown based docs, right? And the reason is because it allows for version control docs, it allows for stable docs, and there are also really great projects like Docusaurus made by Meta. There's also GitHub pages. There's also, I think there's a Jekyll site, I believe it's called. All of these allow you to use your Markdown files and make really pretty sites, right? So in our company, we're moving towards having basically this Docusaurus setup, and all you do is you basically create these Markdown files, push them, and then your docs are available. And it's a really nice way, and it's a very developer friendly way to basically create documents. Now, the benefit of this is it allows us to open source documentation and allow for collaboration, just as you would allow for a collaboration in code, right? So you can have a centralized repository of all your docs, and someone can fork it, add docs, someone can create another branch and modify docs, etc. So it's really collaborative, and it allows for it really easily. And there's a great Markdown guide here. What I would say is right now it's not super important, but I want you to go try experimenting with it and learning how to use it, because it'll be really beneficial in the long run. I see a lot of companies moving towards Markdown, and we can quickly go here, but there's a great guide here, markdownguide.org. And you know, in the lab sample, you'll see a Markdown file. It's .md, which is why I just wanted to quickly cover it. Okay. All right, so now from here, let's get going. Haha. No, I'll see myself out. Okay, no, I'm kidding. Okay, now, there's a few things I want to call out. So all assignments going forward will be using Git, okay? Now, we use this thing called GitHub Classroom. So every single assignment has a different Git link. Please do not put all your assignments in one Git link. We will not be able to grade that. It's every single assignment has a different Git link, okay? And one thing I really want to call out is please, please do not wait until the last minute to submit this week. This is the first time you're using Git. There will be issues, and we want to resolve those ASAP. We have a lot of office hours throughout the week, which the schedule should already be posted. So please hop on by, and you know, me or one of the TAs will be happy to help you and get everything resolved. Now, we will now go through a sample assignment, which will allow you to like kind of test Git and make sure it's working. And there may be issues, so just let us know as soon as you run into them, right? Go ahead and, you know, as you're doing the sample assignment, even just, you know, go ahead and submit a ticket, right? So just go ahead, submit a ticket, and, you know, we'll be happy to figure it out as soon as we see it. So, yeah. All right. So here I've attached some resources. So the Git info sheet, the GitHub, right? The Git practice assignment, and a Git cheat sheet. So we'll talk about the cheat sheet like in a little bit later in this lecture. But for now, let's go ahead and get started with the practice assignment. Okay, so what we'll do is we'll go ahead and open up this classroom assignment. So remember, this link is unique every single time, right? So for lab 2, in the top of the doc, there will be a link. And you'll go ahead and you'll click it. Now, here what you'll see is you'll see a bunch of things, right? And what you'll see is, hey, a bunch of names, right? So first thing here, go ahead and click your name. If you cannot find your name, please let us know ASAP. Open up a ticket, let us know, because otherwise your grades won't be able to be inputted, because this is the way we link it to Canvas. So please let us know ASAP if you don't have a name here, and don't just click a random name, please. It'll mess up someone else's grade, might mess up your grade, so we don't want that. So just go ahead and click your name. Okay, so once you click your name, right, it'll say, hey, go ahead, accept this assignment. So we'll go ahead, click accept, right? And it might take a second, but basically, here we go. So what happens now is it goes ahead and it creates a Git sample. Basically just the assignment repository, right? Remember, repository is just a folder, right? So what you can do is go ahead and click this, right? So now here we go. Look at that. That's pretty cool. So what you'll see here is a few things. So first, this is the GitHub UI, right? So there's a lot of things here. Not all of them are relevant, but you can see basically this is the file. So right now in this repository, there's only one file. That's the readme.md, right? Now the other thing that's very important is at the top left, you'll see a pull requests, right? And you'll see one open pull request. Please do not close this. This is auto-generated and is used for grading, right? So please keep that open. You don't have to worry about that, but just keep it open. And then from there, there's just some other cool things in this UI, right? So on the left here, you'll see main, right? This is your branches. So you'll see there's 2 branches by default. Again, do not delete this branch. We need it, right? So there's a feedback branch and there's also a main branch, right? And you can also go and create new branches, right? And then outside of that, there is a code button. Now this code button is really important, right? So this code button is actually how you will be able to clone the repo, right? So the first thing is this step does require you to have SSH set up. So if you haven't gone, pause this video, go ahead, go back and set up SSH. Now, what you can do is go ahead, click code and click SSH, right? So this is very important. So go ahead, copy this, and then go to a terminal, right? So in Mac, it should be terminal. In Windows, you might have to use PowerShell or Git Bash, whatever works. So go ahead and copy that link. All right. And now just go to wherever you want your code to be saved, right? I recommend having like a workspace folder or something. And what you're going to do is you're going to type git clone, right? And you're going to paste that link and click enter. And there we go. So now your repo should be cloned, right? Now what you'll see here is when you clone a repo, right, it says cloning into something, right? So what this is, it's saying, hey, I created a folder called this, right? For you, it'll be slightly different. For me, it's this, but it says, hey, cloning into this folder, right? So what you're going to do now is go ahead and open up that folder in VS Code, right? And one thing I want to call out is you're going to do this for every single assignment. So every single assignment, you'll get a new repository. You'll type git clone and do this. So now from there, let's go ahead, go open a VS Code. Okay, and here you might have your old code open. What you can do is click File, New Window, and you'll be able to, here and go to Open and go ahead, find your folder. Okay, there we go. Cool. And with that, your folder is open. Great. Okay. So now let's take a look here, right? So first of all, ignore Copilot. But here you can see we have a readme.md, right? So this is that markdown file that I was talking about. But basically, this is how we're going to demo how Git works. So what we can do is, let's say we go ahead and we create a new file. So let's go ahead, click new file, call it test.html maybe. Okay. And what we'll do here is we'll just create a very basic kind of title. Add to title, and we'll say title oh, you know what, I forgot something. I forgot the HTML tag. There you go. Then do title and do this is a test. Okay. And then that's it. Okay, that's all we need. Cool. So now 2 things to call out here. So first thing you'll see is that this file is now green, which is pretty interesting, right? What does that mean? So what that means is Git basically is saying, hey, this is a new file, right? And you're like, yeah, obviously, right? So now let's go ahead back to our desktop and be like, hey, I added this new file. Let's refresh. I don't see it, right? And you might be like, hey, you told me that this would happen, right? And great question. So the way Git works is pretty interesting, right? So Git, as we mentioned, has this local kind of repo, right? So what you need to do now in Git is basically go ahead to your local repo and then first stage your file. So basically you need to tell Git, hey, I have this file, I'm going to stage it and then commit it, right? So what that means is I'm going to stage it, say, hey, I'm ready to basically make this change. Commit basically says, hey, I'm making this change to my local version. And then what you have to do is then take that change and push it to the remote. Remember, this is GitHub, so this is the remote, right? And only then will you start seeing the file, right? So let's go ahead and walk through that, right? So what we'll go here is click New Terminal here. And we'll go ahead and type git status, right? So what you'll see here is that, oh, you're on branch main and your branch is up to date with origin main, right? That means there's been no changes made. But now it says, oh, you have a untracked file, right? This means that, hey, it hasn't staged or anything. So what you need to do is type git add dot, meaning add all the files in this folder, right? Now, if we do a git status again, it says, oh, cool. Your branch is still up to date with main, but now you have changes to be committed, right? So now from here, you're going to type git commit -m, and here you'll type something like feat adding new HTML file. Okay. Now, what does -m mean? That means message. So each git commit needs to have a message. So you can put you can just put something, but this is a nice way to do it, right? So there's this concept called conventional commit, right? So conventional commit is basically this commits, right? So basically it's like a very nice way to make commits, and it makes it like a lot easier to understand. So like feat : chore : all these other kind of things, right? Okay, so now let's go back to VS Code. Anyway, so now if we do a git status again, after the commit, you'll see, hey, okay, on branch main, but now your branch is ahead of origin main by 1 commit, right? And it says use git push to publish your local commits, right? So now what we can do is we can type git push. All right, sorry about that. My git, I have multiple git profiles, so I had to do a little bit of hacky stuff. Anyway, we're back. All right, so now we went ahead, we pushed, right? So I did a git push, right? And so what we can do is now go back to Chrome, and what we can see if we refresh here is that, hey, look at that, our test.html is there, right? Isn't that pretty cool? So now what you can do is you can see, oh, okay, I just committed this. Here's the file. You can even see the file, right? If you go here, and you can even say who committed the file, right? Git blame, I did, right? So it's pretty cool, right? So now one thing that I see is a lot of students have errors with pushing or something like that. So before submitting an assignment, right, please make sure to go ahead and verify that, hey, I see the code has been updated, right? And as you submit assignments, you're going to send this link, but very important. So just very important as we go forward, right? All right. So now that's pretty cool. So now let's go back to VS Code, right? Now, what we can do is we're going to do a hidden file, right? So how do we do that? So let's say we have a new file. We're going to call it .env, which is a pretty common name, right? And here we'll have a my super secret password equals super secret please don't expose, right? So now what you'll see is if you do a git status, right, you'll see that, hey, this file is about could be committed, right? Which is what we don't want, right? Because if this leaks, that's really bad, right? So what we can do here is we can create a new file and we can call it .gitignore. And in this .gitignore, what we'll do is we'll just add .env, right? That's it. That's all we're going to do, right? And now what you'll see is suddenly the .env became gray, which is pretty interesting, right? So what does that mean? So now let's do a git status, right? And now you'll see the .env is gone, but the .gitignore added, but the .env is gone. So now we can go ahead and add this, right? Git commit -m chore adding gitignore and git push. Okay. So now you'll see that this .env exists, the .gitignore exists, but if you refresh here, in the .gitignore, there will just be a .env, and the .env is not here, which is exactly what we want, right? So this allows us to basically make sure that, you know, like we don't commit the .env ever by mistake, right? Okay. So now from here, what I want to basically talk about is basically, so this is how you submit an assignment. So once you push an assignment, that's basically it. That's basically the assignment, right? So what you can do from here is we can, what I did is I created a cheat sheet. So if we go here, you'll see a cheat sheet here, and you can go ahead and click it. And in this cheat sheet, right, basically it walks through all the steps. So just like we walked through right now, go to the GitHub link that changes every lab, right? Accept the assignment, go to the repo link, clone, right? And then all of these steps, right? So basically exactly what we talked about, and cool, right? So if you ever have a problem, go ahead and just do that, right? So with that, that is basically how we use Git. It's pretty simple, pretty easy, right? Now, what I do want you all to do is please go ahead and try the sample assignment. Let us know if there's any issues, right? We're happy to help. Some of you might have Git issues. Some of you might have SSH issues. We don't know. We can't know. There's hundreds of different configs that people could have on their computers. So with that, that is all I had, and I will see you all in the next lecture this week, which is actually talking about the content, which is HTML and CSS. All right, see you all then.